Today I'm going to do a quick overview of the Pi3Cart from Pi3Cart.com. We're in the fulfillment stage of our Kickstarter right now, so pre-orders aren't quite available yet, but as soon as the Kickstarter rewards get done, we'll have them available for purchase. I'm also going to walk you through how to build your own using the kit from Pi3Cart.com. So to start with, on the faceplate, you've got your two USB ports, the Raspberry Pi's combined AV port, HDMI, your 5-volt micro USB power input, and the two fiber optic LED status lights. This top fiber optic rod actually has a momentary push button behind it that you can use to set up as a shutdown button in your software. Now, if you got an assembled Pi3Cart kit, the first thing you'll need to do is open it up and install your micro SD card. So all you'll need to do is remove 3 screws here and then pull the top off. Now you want to be careful so you don't just yank the Raspberry Pi out. But as you can see, the micro SD will just slot right in here, and then you can put the lid back on. This one has the 2 USB ports for the 4-port expansion, which will let you put USB dongles for wireless controllers, USB storage devices, things such as that. And if you wanted, you could take these and cut into the side and mount them over here for 4 controller support. You want to be very, very careful with this because these wires under here can be kind of fragile, so you don't want to break those off moving it around a whole lot. Now, if you want to change out the faceplates, all you have to do is just lift this up. It's not glued in or anything like that, and then you can just pull off the faceplate and put a new one on. You want to be careful to line up these rods over here, and then you can just put it back into place. Once you've got your SD card in and all of that, then you just snap the cover back on, and then you just put your screws back in and you're ready to go. Now let's move on to how to build this thing. Now when you get your parts kit, it'll have multiple little bags in it, which I've kind of split up by sub-assembly basically, so that you can just go through it step by step to build each part. Now this is going to be your label right here, which is taped on this piece of cardboard just to kind of keep it from getting bent up. But every kit will come with a copy of this label. And you'll have your laser cut faceplate as well. And if you ordered any additional color options, they'll be in there. One thing to note is with these faceplates, you will need to peel off the protective backing, which sometimes can be a little tricky to get started. But you just kind of have to pick at it a bit, and once it gets going, you just peel it right off. And on the black one, that'll be on both sides. I do want to note that the mirrored ones will have this kind of gray back on the non-mirrored side. You don't want to try to peel that off. That's part of the mirroring. So for the first step, you'll need to remove the USB ports and the Ethernet port from your Raspberry Pi so it can fit in the case. Now for working on the Pi, I highly recommend some kind of a PCB holder. This one's pretty fancy. I got it on Amazon. I think it cost about 25 bucks. But there are a lot of cheaper options out there, but it's a lot easier if you have something to hold it in place while you work on it. Now as far as removing those ports goes, there are a lot of methods that people use for removing solder. You can use a solder wick, which you just kind of stick on there and put the soldering iron on, and it sort of soaks up the solder. There's these nifty spring-loaded solder sucker things, which you can use. I personally use a pretty fancy vacuum desoldering tool, it's like a soldering iron with a vacuum pump in it. You put it on there and it heats up the solder, and then you hit the trigger and it sucks it all out. But since I imagine most of you don't have that sort of tool, or if you do, you don't need me to teach you how to use it, I'm going to show you a method that I found that works pretty well for just basic tools. It's somewhat destructive, but it's actually very, very difficult to get all of the solder out of all of these pins at the same time, so that port will just come right off. So what I recommend doing is get a nice old pair of some kind of heavy-duty clippers. You definitely don't want to use your fancy sharp electronics clippers because it will dull them. But to get at these pins, one of the easiest things to do is just go ahead and just mangle the port. If you just clip along with your shears or your clippers, you can get through the shell, which these are very old and dull. And you want to be careful that you don't put too much stress on the board, but I'm going to take this out. But as long as you're not just torquing on the port too much, it shouldn't damage the board. And like I said, this will just about destroy any fine pair of clippers for fine solder work. They're really designed for copper, but if you have any big heavy-duty 10 snips or something like that, that'll be great too. So once you get that USB port pretty thoroughly mutilated, you can see these pins are loose individually, and so you can just desolder those individually, which is quite a lot easier than trying to do them all at the same time. For the next step, you'll want to build the USB subassembly, which includes these parts here. Now there are these two little chunks of USB wire included, and if you want to try to install it with the shield intact and using the shield braid and all that, you can. I don't really recommend it because it's such a short run between the USB ports and where they solder onto the board that there's not too much concern with interference or anything like that, which the shielding is there for. And it's more difficult, and it actually puts some stress on the wire, which can make them break a little more easily. So what I've found actually works better is just to strip the jacket off and yank the don't have my wire stripper set exactly right. Just yank the conductors out of the inside and just use those wires individually. I've got about 1,000 feet of this USB cable laying around, so that's what I'm including for those that want to use it intact. But again, I really don't recommend having to do that. Usually I can just pull these out with my fingers, but there we go. And then, like I said, I highly recommend just working with these wires individually. Now you want to be careful, all these little slivers of metal that come off the shielding, you want to be sure and clean those up and not get those onto your board. That's just death for electronics. So to keep the ends of your wires intact, it's generally a good idea to tin them, which is to say put a little solder on the end, just to kind of hold the strands together and keep them from going all over the place. Now, with the USB ports, they're going to go into the boards kind of like this. And I found that they actually go in better if you sort of straighten out these little tabs here. And you can just use your pliers to kind of flatten them. So ultimately, they'll go into the boards like this. Sometimes they don't line up exactly right, the pins, so you kind of have to monkey with them a bit to get them to go in there, but they'll go in pretty easily. But before you solder this on, we need to put these wires in. So you want to first look at how this goes to be sure that you kind of understand the direction that these USB ports go. But anyway, I've found that if you stick the end that's not stripped through there and the end that is stripped through there, and you kind of pull it down, it'll sort of snap into place almost. And then just fold this wire back towards the other wire to kind of keep it secured. And you want to do that with all 4 wires. And once you get this done, there are a couple of things you want to look at. First of all, you want to be sure that the insulation on the wire isn't poking through that hole. That'll interfere with your solder joint. So you want to just be sure that that's back outside the hole a little bit. And really all this does, by sticking the wires in and looping them back like this, it provides a little bit of strain relief just to make these wires a little tougher so that they don't just break off when you're working with it. You don't have to do this. If you want to just be careful with the wires while you're building it, you could just solder them to the pins on the other side of the board or something like that. But anyway, once these are looped through like that, then you'll want to take your USB port and stick it back on. Now, the easiest thing, of course, is to be sure that like these flat pins are on this side of the wires that are going through, not really next to them or behind them, because it's a lot harder to get the port in. But assuming they're all laying nice and flat, it'll just slide right in. And as far as the colors go, the standard for these would be black, green, white, red. So you want to get them that way, and then down here it's the same thing, black, green, white, red. And then you want to be sure that it's sitting up flat against the board, and you just stick a little bit of solder on there. You want to be sure you don't go overboard with the solder here. Some of these are double-sided boards, and for those in particular, it's really easy for the solder to just whip through to the other side and make a big glob on the back side, and then that could short these out and cause problems. But you just solder those real quick. Get this to focus. And you've got a nice, strong, stable connection for those wires. Here's one that I've already finished with both sides. And there's one other thing I want to show you here. You're going to want to ground the housing for these boards. So just use a little chunk of wire. And the easiest way I've found to do that is once you have both ports installed, you can just bend these little tabs over with your pliers like that. And the other port will have one too, and you bend it over as well. And then just stick your wire in there and solder it to that. And that'll ground both housings. And then that wire will go to the ground pad on the board. So here's a board that already has the USB ports installed and mounted up, and it also has the fan attached. But when you go to install these, to solder these onto the board, the main thing you want to look at is in these holes here, it's going to go black, green, white, red. Same thing over here, black, green, white, red. And I like to kind of twist the white and the green wires together. Those are the signal lines. They may not be necessary on such a short run, but generally they are twisted in a USB cable, and it helps with interference and things like that. And then you're going to want to run the ground wire over and just put it in. There's actually 4 of these grounding pads for each port, and just attach it up there. Now, as for the physical mounting of the USB ports, this is the left side bracket, and all you have to do is just drop your ports in and use one of the provided screws through this hole here, to mount that up to the bracket. And then the bracket just sort of snaps onto this side of the board, and there's another hole here, and you just run a screw in there. The back side of this bracket actually has this cutout to clear the surface mount components that are right under here. Once you've got that mounted up, it's time to move on to assembling the bracket that goes on the other side, which looks like this. Now, due to the stretch goals on the Kickstarter, we were able to include the fiber optic rods, which allow you to see the status LEDs on the Raspberry Pi board outside the case, and then the momentary push button and the necessary components to hook it up, so you can use that as a shutdown button. Now, the first step is going to be taking one of these little rods and putting it in. There's 2 holes here in this bracket, and you're going to want this to go in the lower hole like that. This rod will be the red one, which allows you to see the red LED on the board, and then this other rod, which goes in the top hole, will be for the green one. Now, you're going to need to trim these to fit, and you'll want to look at your board and kind of get an idea of how tall these LEDs are. They're really not tall at all. Probably not even like a 1/16 of an inch, maybe. So you don't need to provide that much room for it, but it does need a little bit. So, and I don't know if you're going to be able to see this very easily, especially with this thing being black. But basically what you're going to want to do is get your rod kind of held into place where it goes, and then use your clippers to get in here and just clip this off right where about where you think it needs to go. I'm actually just going to take this out. For this front rod, it really doesn't need to be much lower than where the bend actually is in the rod. So you can just clip that off. I may have clipped that a tad short, but it's really not that crucial as long as there's clearance for it. And the thing to note, yeah, that's a little shorter than it would have to be, but your board's going to sit flat with this surface down here. Whoops. With this surface and mount up there, so you'll just want your rod to sit, the end of your rod to sit up just a, well, get this where you can see it. Yeah, you're just going to want the end of that fiber optic rod to sit up slightly higher than this surface here, so there's room. And I've also found that using a little bit of super glue or some kind of tape or something like that, electrical tape, a little dab of that to hold this rod in place, just to keep it from slipping around, helps. Personally, just a little dab of super glue seems to work best. You don't want to use a whole lot because you don't want to mess up the optical qualities of the rod, but just the smallest amount you can get on there is enough to hold it in place. And then this rod will just slip in and you'll trim it the same way, just kind of line it up. And use your clippers to kind of get in there and just quickly clip the end off. Now you'll need to build the assembly for the for the momentary push button, the shutdown button. So there's this little dab of printed circuit board that I've included, and you may want to kind of inspect this quickly. And just be sure there aren't any like little slivers of metal that are loose from the solder pads. Those could get down in your electronics and cause problems, but if there are any, you can just kind of scrape them off. Or if they don't want to come off, then you're probably fine. But a little hobby knife will help there too. Anyway, and then this switch will go in. Once again, it's a little easier to sort of flatten the leads a little bit, just to help it go in. And then, so you want this big hole down like this. Hold the board in this orientation. And then the switches, now this is important. So you can see where the leads come out on the same side of the switch. Then there's a side where they don't. This is the side that you're going to want to put into the board like this. Otherwise your switch won't work. And you just get that lined up and push it in. And it may take a little bit of kind of wiggling to get it lined up. You want to get it set so the switch is sitting flat against the board. And it's, you know, reasonably well kind of centered up between these pads here. Now there are two resistors that I've included in the kits. You really only need the one with the red band. I don't know if you'll be able to see this, but anyway, there's a brown, black, red, and then gold band. This red band is the important one. This is a 1K resistor. The other resistor is a 10K. It's brown, black, and then orange. You really probably don't need that one. It's included, so if you want to install your own external pull-up resistor, you can in the circuit, but it's really not necessary. In fact, you could get away without using this other resistor, but I really don't recommend it because if you don't have your software set up right and you hit the button, if the GPIO pin is set up as an output, then you're just shorting out your GPIO and you can fry things on the board and it's not good. So putting this resistor in is just kind of a safeguard against that. The best way I've found to do that is just to kind of bend this tab over here in a bit and then just stick it in through there and leave yourself a little bit of room to solder. And just solder it in place. So now as for running the wire from this assembly over to your GPIO pins on the Pi, again, there's a couple different ways you can do this. You choose what's best for you. I've included this little chunk of 2-conductor wire, which you can strip and use that if you want. I discovered, actually after I started packaging these kits up and building them, a little bit of a hack, you might say. When you install your fan, you don't need this big long wire on the fan, so we'll be cutting that off. But this connector on the end is actually kind of useful for the shutdown button. So what I've started doing when I build them is just clip that off and then actually use it for the shutdown button. If you have a little bit of heat shrink, you can use that. And just put it over the wire before you do this. And just twist it around this resistor wire as neatly as you can. Try to get it to lay kind of flat against the wire. And just push it up close to the resistor. And put a little solder on there. Then you can just clip this off short again. And the heat shrink will do a couple of things. It'll insulate it, and then it'll also provide a little bit of strength to that joint. So, and you can even push it up over the resistor a bit. And then for this other side, all you have to do is just solder it up to this leg over here. These boards are actually intentionally cut so that these bottom leads don't go through any holes on the board, because there's actually some clearance issues underneath there with some of the components on the board, so it's just easier to leave that open like that. And a little bit of heat shrink can help, or electrical tape, or just whatever you've got. And there you go. And then all you have to do is put this on here, mount it up with the screw right through here. Remember, you want to do the resistor in the top left corner and this wire in the bottom right corner. Otherwise, if you do them both on the top, the switch won't work. But you'll just line this up here, get it all in place, and then put your screw in through here to mount it up. And you can test this top button to be sure it clicks when you push on it, and you should be good to go. The only other thing that would need to be done is to put your faceplate on here, and haven't peeled the backing off of that yet, but that's okay. And then just trim these. Again, you need to trim them to length. It's important to note this. Okay, if we look at it like this, this is the bottom of the board. So this bottom rod, you can just clip off right even with the board. Like that. But this top one, you want to be sure and trim it, because it needs to be able to move some when you push on it. Just trim it to where there's, you know, maybe a 1/16 of an inch or a millimeter, right like that. And you can kind of set that to your preference after you sort of get used to how it works. But that way there'll actually be a room for it to wiggle in there. And you can wait to do this until you've got everything more assembled, so you can try it out and see what you like. And then you'll just mount it up to the board. Now, another kind of a little hack that I've discovered that actually makes it work a little better is with this 2-conductor wire that I included. If you just, when you strip the end of it, even if you're not using it, you can do this. This jacket actually is just perfect for cutting just a very tiny little amount of it off and actually gluing it into place over this front LED. I don't know if you can see that. It's not strictly necessary, but what it does is it kind of helps. The light from the two LEDs tends to get into both rods, and so you end up with the lights on the front of the housing both showing up red and both showing up green when the green light comes on sometimes. So I found that just putting a little shroud around just the front LED, you don't have to do both, but you can see that it'll just fit perfectly over that LED. And again, just the tiniest little amount of like super glue or something like that helps. Another option would be just between these two rods here, stick a little piece of electrical tape or something like that in there, just to kind of block the light between the two. But that's kind of up to you how you want to do it. So when you go to connect the switch, it's actually really easy. I like to use the GPIO 17. That's chip numbering. So as far as pins go, it'll actually be the 6th pin down here, and then there's a ground here. So the easiest way, if you're using the 2-pin connector from the fan, is to just use your pliers and carefully, or your tweezers or whatever. Actually, there's an even easier method I found, and that is to just go ahead and put this on those pins. Now, you can't just use it like that because of clearance in the case, but you can just very easily just bend those down just carefully so that the pin actually, or the connector actually goes out towards the front like that, and then you're good to go. Again, this is pin 17, so when you go to set up your shutdown script, remember that. You can solder them onto any of these pins if you look up where they are and which one you want to use, but I like 17 because it's down towards this end, and it's not used for any other purpose on the Pi, so it's just a plain old GPIO pin that's not going to be used for anything else. And then for hooking up the fan, again, I like to cut the wires pretty short. The fan's going to go actually right like this in the case, so these are actually even a little longer than they would have to be, but having a little bit of room to work there is not bad. And then I actually put them up through the mounting hole on the Pi, and this is another way to just get a little extra strength on those. And then usually I just solder straight to the pins. Sometimes I've desoldered these connectors and soldered straight to the board. You can do that if you want. You know, it's up to you. But the thing to note is that this is the 3.3 volt pin here on the end, and then on the end here is 5 volt pin. I'm not sure if you'll be able to see that on the camera real well, but it's the one on the end. And you can look up a diagram for this. They're all over the internet. I actually highly recommend you familiarize yourself with what all these pins are if you haven't already. And then the third one down from the ground, from the end, is a ground pin, so you can use that to hook the fan up as well. Now we will need to trim the inside of the cartridge right here, so this will all fit. I'm going to use this nifty lime green cartridge. It's just one I happen to have on hand right now. And what you'll want to do is just, the easiest way is to just use some good sharp clippers, and then you're going to want to clip these little, I don't know, walls here. And to start out with, I just clip them right there where this little notch is, just right on the end. It's important not to clip them all the way up here, because these little ears are actually important for holding the Pi brackets and everything in place. So if you just clip those right there like that, then you can use, and be careful that you don't cut yourself, but use a good sharp knife. You can use a hobby knife like this is probably your best. You could use a box cutter or whatever, just be careful. And just right down in this corner, just push the knife along, and you're not trying to cut all the way through it here. You're just kind of trying to just score it a bit to get it started. And you can just go down a couple of times to get kind of a good groove going there. And then same thing here. Just be careful and don't let it slip and stab yourself. But in fact, you don't even have to do this side, but it kind of helps to have just a little bit of scoring across there. And then it's just, you can use your pliers. You can actually just do this with your hands sometimes. Just push it over like that, and it'll just fold right over and pop out. And that's what you're looking for. Again, you want to have these little ears left. Now, you will probably need to trim those a little bit later, especially on this top side. But I like to start with that and then just start see how everything's fitting, and then go from there. So, same thing here. Just clip that. Do a quick little scoring cut across there. That one kind of went up a little bit on me. And just once you get it started, it's usually a lot easier to just kind of push it over. And just break it out. Now I will say, having done a lot of these, I happen to know right offhand that this side over here, and this is going to be the top of the cartridge, like the label would go here, and just turn it straight up. This side over here is going to need to have this here completely cut out. And that's because when you go to put this in, it doesn't actually, there's not quite enough room behind the USB ports here for it all to fit. And you can play around with it a bit and see how it works for you, but it tends to make it to where the faceplate doesn't like to go into place. But if you just cut this one ear out, then everything fits better. And then on this other side, this will actually probably need to be a little less than the full width here. So just cut it, I don't know, about in half. I mean, you don't need a lot, left of these, just enough to catch the edges and keep it from sliding around. So this one actually doesn't have my other bracket mounted up right now, but anyway, the Pi will sit in like this, and you can kind of wiggle it around and see how it's fitting, and stick your faceplate in and see how that's going. So once all that's done, all that's left to do is to mount up your fan. Now you can use some glue, super glue, hot glue, whatever, to glue it in place. I actually really prefer to use a good strong double-sided tape. It sounds silly, but I really like the way that works, because then it's easy to just pop the fan out if you want to put it in a different cartridge or something like that. But it is still good and strong, and it won't just pop loose on its own. But if you really apply some force, it'll just pop out, and you can throw this whole thing in a different cartridge if you wanted. And then you'll just want to, for what it's worth, this is the top side of the cartridge we're working with here. You'll want to do that. The fan, when you go to put it in, you'll want to sort of line this up. You'll want to have already kind of played with the faceplate some, put the shell on, gotten used to how this thing sits, how it fits in here. This bracket goes back up against this little ear here. So you want to get everything lined up. I mean, it is pretty loose without it everything being closed up. So you want to get a feel for where that board's gonna end up, and then put your fan back here to where it's just almost touching. Maybe leave just the slightest little gap here. But it's important that this is the intake side of the fan. And the idea here is that this fan lines up with the board to keep the air that's blowing out of the fan from just immediately getting sucked back into the fan. But then all that's left to do is install your SD card, snap on your faceplate. Again, the critical thing here is to just get these rods lined up, and of course this top rod is a little loose, so it takes a little bit of lining up. But get that on, be sure the faceplate is sitting down in this little groove here behind this little ledge, and it should sit back there nice and snugly. And then just snap your shell back on. Since this board can wiggle a bit, you want to be sure it's kind of settled towards the front, like towards the side as much as possible. And then just kind of snap it in place, and just sort of, it may take a little bit of jiggling the first time to get it all set up right, but just get it all snapped on, put in your screws, and there you go.